Alright guys, you're welcome to the next tutorial series in our deep learning lecture. Today we shall be looking at the different variant of the gradient descent. In another video we'll look at gradient descent algorithm itself. But here we just want to quickly understand the different variant of gradient descent. There are basically three types of the gradient descent. You have the stochastic gradient descent, you have the full gradient descent, or it's also called the average gradient descent, and you have the mini batch gradient descent. Now if you look here, this is the mini batch gradient descent. This is showing us mini batch. And what does this say? Essentially, in gradient descent algorithm, you calculate the error on your training instances and you back propagate and by differentiating the error with respect to the weight, so that you'll be able to update the weight in direction of the global minimum. So here we are calculating the total loss, total error, based on the training set. This is the training set, the instance and its label, and we are calculating the total error, how this differs from the prediction. So we sum up all the errors and that gives us the total error. But the point is, at what point do we update our weights? That is what makes the difference between all these variant. If you update the weight after each example has been passed through forward and backward, then that is stochastic. If you update the weight after the entire training data set has been passed through forward propagation and backward propagation, that is full gradient descent. But if you update the weight after a number of examples, a specific fixed number of examples of the training instances has been forward prop and backward prop, and that is referred to as the mini batch gradient descent. So here it says that the full sum, that is the full gradient descent, is expensive when n is large. So approximate the sum using a mini batch of the examples. How does the mini batch work? You take a sample, you forward prop it through the graph, get the loss. Once you are done with all the samples, you add up all the loss, you back propagate to calculate the gradient, then you update the parameters using the gradient after all the number of batches in the number of subsamples has been completed. And this graph shows what happens when you do batch and when you do mini. You see that when you back propagate your error and update the weight matrices after you have passed through all the entire training instance, the curve is smooth in the direction of the local minimum. But when you do mini batch, you see that the error jitters, that is, it tries to move away sometimes from the direction of the local minimum, but still comes back to it. So when you're comparing the three, the batch here is used to refer to as the full batch, that is the full gradient descent. and this is the stochastic. You can see the stochastic is the one in pink. You see here that when you update the weight matrices after each sample, it takes more time to converge and you tend to even move in the wrong direction. The red point is where the global our global minimum is. That's our destination. So you see that it keeps moving away, it keeps meandering away from the global minimum. But if you look at when you use the batch, which is the entire training set, you see that it moves smoothly at every step. This is one epoch. From here to here is one epoch, another epoch, another epoch, another epoch. You see that it moves smoothly into the direction of the global minimum, while the mini batch is just in between these two. And typical mini batches, depending on the memory size that you have, is 64, 128, 256, and 512. The same thing is explained here. You have the full gradient descent. It's also referred to as the batch, like we saw, or average or full. You update the weight once for each training sample, for each training example. So this is okay, sorry, this is stochastic, where you update the weight for one example at a time. Like we mentioned, you update just one example at a time, and you update the weight one example at a time. For the full batch, you update the weight after one data set. This is the batch. It's also referred to as the average of full. So the network calculates the weight data over the entire data set, then changes the weight only after it has computed a full average. Okay, Y batch is referred to as the mini batch in our previous example, which is just after a set of n samples. Thank you for listening. See you in the next one.